Assalamu alaikum. So in this video we have generate two signals and then we will make a correlation using convolution, and then we will use built-in function this xcore to find the correlation. First we will correlate x1 and n2 and then x2 and n1. By changing this position we will see what happens. And our goal in this video is not to just mathematically do the correlation. Rather, we have to learn by watching the output how to make a decision about the two signals. Okay, so in this video we will try to find the significance of correlation. Okay, so let's start. So let's say you have a signal x1 that looks like that is any random signal, and x2 may be any random signal, but in my video I have take a shifted version of x1. So this is the shifted version of x1. Okay, now I have to make a cross correlation between them. So cross correlation, and my cross correlation function CCF, cross correlation function is rxy. This defines the relation between x1 and x2, and it is the function of L, and the formula for this is x1 n x2 n minus L, where n is from minus infinity to plus infinity. Okay, now let's rearrange this equation. Let's take x2 n minus, let's assume that x2 n is equal to zn. Okay, z minus n. So similarly zn is equal to x2 minus n, right? Okay, so now let's take x2 n minus L. So that means I have written n minus L instead of n. So here I have also write n minus L instead of n. So that means it is simply z L minus n. Okay, now let's put it here. Then I will get x1n, and this is x L minus n. And what is this? If you remember the formula of convolution, you can easily understand that it is actually convolution between x and z. And what is z? Z is x2 minus n, but here we have L, so z is x2 minus L. So this is the formula. So this is the formula for cross correlation using convolution. So what we need to do, let's go to our code. So this is my code. So first I have generated signal. This x1 are the values. This is not the main signal, these are the values. Okay, so x1 is the value and n1 is its time index, and this is the signal shift function. This is written by me. In the previous videos I have discussed about this simple shifting function written by me. So signal shift, it will shift the signal by 2. That means this signal will be shifted to the rightward by 2 unit. And then if I plot this signal, the signal will look like this. This is the original signal, and I haven't plotted the shifted version of the signal, but it's okay. So x1 is the original signal and x2 is the shifted version of the signal. Okay, now let's talk here. Okay, so let me go first here. So first of all, you see that I have to make a convolution. I have to make a convolution of what? Of x1 and not x2, the folded version of x2, right? The folded version of x2, that means x2 minus L. So what can we do? We can fold this signal by using signal fold function. So by using signal fold function, this is also a function written by me. Let me show you that signal fold. So here is the it's the signal fold function, a 3-line function. very easy. So signal function, and I will pass x2 and n2, and I will get the x2 fold and n2 fold, and then I will use this x2 fold here, and I will get what I will get r. So this is my cross correlation function, but observe that it's our code. Okay, so it's our code, but observe that we don't have any any information about L, right? As R is a function of L, but we don't have any information about L. So how to find this L? So by convolution theory, we know that this L has a starting position and has a ending position. And what is the starting position? This is simply the time index of n1, time index of x1's first value, plus this folded time index first value. As you are folding x1 and x2, so you have to take the first element of their time indexes, and then you have to take the ending element, the last element, and if you do this, you will get the information about L. So let me go to the code. So see, first I have fold using the signal fold function, and then I have convoluted and find R, but this is only the value of the cross correlation function. But what I need the information about L. So see, I have do this. I have convolute x1 and x2 fold, and that's why I have taken the first element of their time index, and again I have taken the last element of their time index, and then if I plot L versus R, let's see what happens. Okay, so this is the R, this is R, and you see that at -2 it has the peak value. So at the end of the video I will show you why at -2 you have the peak value. Let me show you another thing. If you shift it, you have shifted it by 2, right? Let's shift it by let's say 4. Now let's see what happens. Okay, so you shift it by 4, you see you have a peak at -4. So this has a significance. By seeing the peak value, we can understand that how much the signal has been shifted, how much delay these two signals have. So we will talk it more about at the later, and let's do it 2 again. So this is, I have edited at 2, and let's delete this thing. Okay, let's start from the beginning. It is my original x1 signal, and the correlation signal looks like the correlation and the correlation signal looks like this. Okay, let's start. So this is my this is built-in function. Xcode is not my function, sorry, it's built-in function. Okay, but this built-in function gives you core. It is actually R, the cross correlation function, or I can core, and this is LL. I choose it LL, but there is no use of LL. Why? Because this Xcode assume that x1 and x2 started from origin. Okay, or it's actually not true. It's actually not quite true. Let me omit this thing. Actually x1 and x2 are the values. Okay, you see x2 is the value and x1 is the value. Okay, this is not, this don't give you any information about time, and thus cannot give you any information about L. So to get the information about L, you have to you can use this formula. I have two formulas here. Okay, So I have two formulas here. First formula I have already told you about. This is the formula I have told you about. I have used it here and just copy this here. And I have another formula. You can use also this formula. Okay, so let me talk about this. So if you write x core x1 comma x2, then how can you get the information about L? So you can get it in another way. So first, this is you see that if I use this, I have to fold this second signal. I have to fold this second signal, but let's say you don't want to fold this second signal, okay, and you just want to use the original signal's time index. So what can we do? You have to take the first signals first element and second signals end element. This is, and then you have to int at first signals ending element or last element, and second signals time index first element. Okay, let me check it with my code. I have written here plus, sorry, it's not plus, it's minus. This is the difference. Okay, let me tell you, if x core is equal to x2 comma x1, then what can we write? So let's say it's xlp. In our code I have defined it as L2. Okay, let's take this as L2. So L2 will be, you have written x2 at the beginning, so it will first you have to write now n2, and then you have to write n1. Similarly, first as you have written x2 here, so first you have to write n2, and then you have to write here n1. For here you have 1, then int, and now you have here int and then 1. So this is my formula for L. So if you use x1 comma x2, your L looks like this, and if you use x2 comma x1, your L will look like this. Now let's go to our code. Okay, where is our code? This is my code for x1 comma x2. So I have written this L, and then if I run this portion, see, I get a peak at -2. Okay, and this matches with my previous result. So this is the cross correlation function using convolution. Let me see one value. So at -1 it is 36, at -1 it is also 36. So these two signals is same. Okay, so you can find the correlation using convolution, or you can use the built-in function. Okay, now let's see x2 comma x1, and similarly you can use L2 like this, or you can use L2 like this. And see, if you use this thing, if you use this, then you have to fold this first signal. So you have to fold this first signal. It's a hassle to you, so I didn't fold the first signal and directly use this line. Okay, so this is the formula I have previously talked about that. And now if I run this part, I will get this. Okay, now I have some, okay, let's say this is, let me give a title. So this is core of x2 comma x1. Okay, and this is x1 comma x2. Now let me run this code. Now you can understand it clearly. Okay, now see that if you write x1 comma x2, you have a peak at -2, but if you write x2 comma x1, you have a peak at 2. So here you have -2 and here you have 2, right? Now let's try to find the significance of these two signals. Okay, so let me paste it here and let's see what these two signals tell me about. So what was x1 and what was x2? So my x1 was a random signal, looks like this, and this was x1, and x2 is the shifted version. Let me do another thing. Let me shift it by 4, okay, or 5. Let's see what happens. So if I shift it by 5, you see that here you have at -5, peak at the -5 and peak at +5. So now let me copy the let me take a screenshot of it here and then go to here. Let me talk about when I am shifting by 5. When I have shifted it by 5, I have shifted the x2 signal by 5. Okay, so this is my, let's say this is my x2, x1, and this looks like this, and x2 looks like this. Okay, so when you, so if you correlate x1 comma x2, this means that okay, let me first talk about x2 comma x1. When you take x2 comma x1, then it means that it assumes that x2 is advancing. Okay, x2 is advanced, and x2 is advanced and x1 is delayed, and you see that x2 is advanced by 5 unit, so it gives you a pulse at 5. Okay, similarly, what I mean, if you correlate these two signals, then we can assume that x2 is advanced. That means it's, oh sorry what I have told you. Wait 1 minute. Okay, so let me correct myself. So we have to assume that for core x2 x1. Okay, so for, let's work with this. So for x core x2 comma x1, or simply correlation between x2 comma x1, I have to first assume that x2 lagged by x1, and as the value is peak at 5, as peak at 5, so yes, x2 lagged by x1 by 5, and yes, it's actually lagging. You see that this signal is start operation after some time, right? You have 0 here. Let me tell you about this, that this signal starts from -1, then 0, then 1, then 2, but this signal starts from 4, then 5, then 6, then 7. That means it has been delayed by 5, because this signal is starting after some time, so this signal is lagging. So x2 is lagged by x1 by 5 amount. Okay, now let's come here. So x1 is at the beginning, so we will assume that x1 is lagging by x2 by how much? It's -5. So what does -5 means? -5 means, okay, so it's lagged by -5. That means x1 is leading by x2 by 5. So by this I can say that x1 is actually not, as correlation I get a peak at -5. That means no, it's not actually lagging, x1 is leading. But here we assume that x2 is lagging and we get peak at 5. Yes, so x2 is lagging. So by using cross correlation between these two shifted signals, we can understand the shifted how much shifted these signals are. Okay, and one more thing, do you see that this signal is at peak at the at this middle, and it is decreasing here? Let me understand it by this. Okay, so this is x1 and this is the shifted version of x2. So if I I have make a correlation x core x1 comma x2, and what I got -5 at peak at -5, right? I got peak at -5. That means if I shift this x2 signal -5 to the left, 5 to the left, then I will get this. And you see, if I multiply these two signal, and then if I multiply these two signal, as you have a multiplication in the formula, so if I multiply these two signal, I will get the highest point, right? So that's why I get the peak at -5. Because why? Let me tell you again. This is my original x2, but if I shift this, the signal will be shifted here. If I if L is equal to, let's say if L is equal to -5, if L is equal to -5, then x2 will be here. And then if you multiply these two signal, you will get the highest position. And then if L is equal to -4, your signal will be here. And if you multiply these two signal, you will get a lower value. Then you will get again a lower value, then again a lower value, then again a lower value, again lower, and now it's 0. Because why? Because now you don't have any common region between x1 and x2. That means you have some zeros here, and you are multiplying x2 with zeros. So you know this cross correlation function will be zeroed here. So that's why when L is equal to -5, I get the highest value here. Okay, so thank you.